Alright, let's take a look at this distance formula, and also we're going to talk about some parallel and perpendicular lines here. So for the second, third, you guys, and sixth, you guys kind of have these separate, and fifth period, I think you're the one that got them together just because of the days before the SAGE test. So we're not going to do a ton of problems, just kind of some main ones, make sure you know what's going on. So remember that distance formula. We derived it from the Pythagorean theorem. Okay, dealing with those right triangles, the two legs are A and B, the hypotenuse is C. So that hypotenuse is generally that segment we're dealing with. Okay, the distance formula we write like this: x sub 1 minus x sub 2, or you can write it x sub 2 minus x sub 1, really doesn't matter, squared plus y sub 1 minus y sub 2 squared. Okay, so there's two ways you can do most of these problems. Okay, if you want to, I think the easier way is to simply make that triangle when you're given the graph, and then count the lengths, and then go 4 squared plus 2 squared equals, call that length c squared. 4 squared is 16, 2 squared is 4, 16 plus 4 is 20. Take the square root of that, and we get our answer equaling, now if we want to leave it square root of 20, technically you can reduce that, so let's probably just go with the decimal. And I think it does tell you to round to the nearest tenth, probably in the homework or something like that. So take the square root of 20, and you get 4.47, so 4.5, pretty much. Okay. So that's an easy way to do it using that idea of Pythagorean theorem. Now, if you wanted to use the distance formula, you would think of it like this. You need those points. So that point is 4, negative 2. Coordinate here is 0, negative 4. So we've got an x1, a y1, an x2, y2. Doesn't matter which ones you call x1 or y1, just as long as they're the same point. So then we take that x1, and I put in 0, minus that x2, which is 4. Square that plus the y1, which was negative 4, minus the y2, which was negative 2. Square that, take the square root of that. So 0 minus 4 is negative 4 squared. Negative 4 minus negative 2 is really like plus. Negative 4 plus 2 is negative 2 squared. Negative 4 squared is positive 16. Negative 2 squared is positive 4, giving us that same thing, square root of 20, which we got was 4.5 when we rounded. Okay, so two different approaches you can take. So this one, same idea. You can draw the triangle, count the sides, or use the coordinates. Negative 3, 3, and 3, negative 5. So coordinates would be square root of negative 3 minus 3 squared plus 3 minus negative 5 squared. Okay, that would give us negative 6 squared plus 8 squared, which would be 36. Remember, whenever you square a negative number, it's always going to be positive. 8 squared is 64. Add those two together, and we get 100. Take the square root of that, and we get 10. Okay, if you counted 1, 2, 3, 4, 5, 6, 7, 8, notice it comes in the same place. The y's, the vertical, 1, 2, 3, 4, 5, 6, same place. The horizontal, the x's. Then 8 squared plus 6 squared equals c squared, call that c. So then we get 64, 36, add them together to get 100 equals c squared. Then you take the square root, just like we did here. So you're basically doing the same thing, it's kind of how you want to think through it. Alright, now when I give you points, a lot of times people think the distance formula is a lot easier because you can just go x1, y1, x2, y2. So I just go square root of 7 minus negative 8 squared plus 2 minus 3 squared. 2 2 minus 3 is negative 1 squared, which is just 1. 7 plus 8 is 15. 15 squared, I believe, is 225. Yep. 225 plus 1 is 226, and these are still all under the radical. So, take the square root of that, and we get 15.0. So basically 15. Okay, so that's easy enough to do with these points. Okay, so we do 16. Same idea. x1, y1, x2, y2. So then we go square root of negative 1 minus negative 7 squared plus 8 minus negative 6 squared. So that's really plus. Negative 1 plus 7 is 6. 8 plus 6 is 14. 6 squared is 36. 14 squared is 196. Add those together. We get 232. Take the square root of it, because this is all still under the radical. And we get 15.23. Basically 15.2. Okay, there is another way you can do it, thinking more about that triangle aspect. And remember, if you kind of went here, when we subtract the x's, that gives us that number. When we subtract the y's, it gives us this number. So, if I rewrote these on top of each other, and then I go negative 1 minus negative 7, that would give me positive 6. Then 8 minus negative 6 would give me 14. And then I could add them together, square them, and set them equal to c squared. Then we'd come up with that same thing to get our same answer. So that's kind of another way that you can think through it. Alright, so there's a distance formula. So basically, that's the main point of that homework for second, third, and for sixth. And we do have some review problems. I'll go over a couple of those. I'm not going to go over the graphing with slope-intercept form or graphing with standard form, because we've already done those a lot. Just a reminder, if I give you the x and the y-intercepts, x-intercept, let's go to that point on the x-axis, y-intercept, point on the y-axis, and graph it. Okay, the geometry stuff we just went over, we're reviewing some of those problems, so I didn't put those on either. But solving an equation, just remember, if you got parentheses, use distributive property. Multiply it by each piece. 8 times negative 1 is negative 8. 8 times 5 is 40. And then we need to get the variables on the same side and the numbers on the same side. So I could add 8 to both sides, giving me 40b equals 7b plus, what is that, 33? Subtract the 7b to get over with the 40b. So we get 33b equals 33. Divide by 33. And b would equal 1. Okay, now this part will be basically for second, third, and sixth. This will be your next time's homework, so you'll need to come take a look at this for that part. For fifth period, you got it all together. So, parallel line. Remember, the whole point of parallel lines is that they have the same slope, and they have different y-intercepts. Okay? So, if we look at 35, slope of negative 5 over 4, y-intercept of 0. So, the slope of a line parallel is just the same thing. Slope of negative 3/4, parallel line slope is negative 3/4. Okay, now perpendicular. Perpendicular are the exact opposite. Okay, these lines are perpendicular. They meet at a 90-degree angle. The slope of one is basically what we'd call the opposite reciprocal of the other. So if I have a slope of 1, let's go 1. Now let's look at one of our problems. So my slope here is 2/3. So it's positive, so the opposite would be a negative. The reciprocal would be flipping the 2 and the 3, so it would be 3 over 2. So if I graphed 39, we'd start at -1, we'd go up 2 to the right 3, up 2 to the right 3, look something like this. Okay. So if I graphed this other one, it would need to have a slope of -3/2, so I'd be going down 3 and to the right 2. Okay, so let's say I started right here. So I go down 3 to the right 2, down 3 to the right 2, and it would look something like this. Okay. The way you can tell if two lines are perpendicular is if you take their slopes and multiply them. They'll end up being -1. 2 and -3 is -6. 3 and 2 is 6. 6 over 6 is 1. The negative stays. That's how you know if two are. So the process in finding the slope perpendicular, take your slope, so that would be -1, make it a fraction, get the reciprocal, and do the opposite. So it was negative, it becomes positive. 1 over 1 is still 1. So a positive 1 would be my perpendicular slope. So now, when you have to apply that to your graph, okay, so look at 43. We want a line parallel to it. So I need the same slope, different y-intercept. So if I graphed this line, it would look like this. So I need a line that's growing at the same rate, but starts at a different point. Okay, that's essentially what a parallel line is doing. So I could go y equals 3/5 x minus 1. So we'd start at -1, and we'd go up to the right 5, or down 3 to the left 5. And your line should end up being never touching, if you were to draw it correctly. But that would work. Okay, this would also work. This would also work. So there's pretty much unlimited options because you can change the y-intercept. So that's with parallel lines. Okay, now with perpendicular lines, that one's a little tougher, right? So if I graphed this line, y-intercept at -1, up 4, out 5, down 4, to the left 5. Okay, there's our line. We need one perpendicular. Okay, with perpendicular lines, you have the opposite reciprocal slope, and you could have the same y-intercept or different y-intercept. Doesn't really matter, just this part matters. So I take 4/5, it's positive, so mine's going to be negative. Swap the fractions, numerator and denominator. There's my slope. Now where do I want to start? Doesn't matter, I could start right here and do y equals -5/4 x minus 1. So I go down 5 to the right 4, or up 5 to the left 4. And then if I draw my line, it would be perpendicular at that 90-degree angle. Alright, so there you guys go. Good luck.